Greetings, ladies and gentlemen, and welcome to our next Big Ideas Lesson 3.4, page 128 for you 8 general students, and Lesson 12.4, page 552 for the 7 accelerated students. We're going to do our last lesson on angles and triangles, and today we're going to use similar triangles to solve real-life problems. Well, we've already used similar figures before to solve real-life problems. So this is kind of going to piggyback on that. We're going to add a little bit to it because today obviously we're going to be using angles. If you look at our essential question, how can you use angles to tell whether triangles are similar? And then once we find out they're similar, we can use that to solve real-life problems. So I know, being a person of character and intelligence, you already filled out those notes from the top of the appropriate page, page 128 or 552. So I'm going to piggyback on that. Just put your pencils, pens down, look, listen, and learn. And of course, always pause when I'm done for you to then write down anything else that you want to. So let's do a quick review of similar, because they didn't do that in the book. We're going to do a quick review of similar figures, and we're going to specifically talk triangles, but they're all figures. So if they're similar, what do we know? That's right. We know that 1, they have to be the same shape. If they're not the same shape, they can't be similar. 2, the angles must be congruent for these figures to be similar. We're going to deal a lot with that today. And 3, we've got the side lengths that have to be proportional. So we've already dealt with this, proportional side lengths. We've done this before. In fact, we're going to do it again today to prove why, if we have 3 congruent angles, in fact, the figures are similar. So what did they discuss today? They said, hey, if you can discover that 2 angles are congruent, then you know the third angle must be congruent, and therefore we have similar triangles. So that's where we're going today. We're not using the proportional sides to discover similarity today. We're using the angles. Well, let's find out why we can do that. So we're going to then do the converse, or the opposite of using proportional sides, or excuse me, the angles. We're going to use the proportional sides, what we've done before. So you can see right here we have this triangle. It's a right triangle. You can see that we have side lengths of 4 and 3. And of course, most of you can remember Pythagorean's theorem. We could find the longest side if we wanted. But we're just trying to figure out if we have proportional triangles. If we have proportional side lengths, if we have proportional side lengths, then we must have similar figures. And if we have similar figures, then the angles must be congruent. So we're going backwards of what they're asking us to do today. So then I'm going to double the side lengths, and I'm going to get this red triangle where I have side lengths of 8 and 6. So I can write my proportion, and I can say, hey, 4 is to 3 as 8 is to 6. If this is true, then we have, in fact, similar triangles. So when we do our cross products, we get 24 is equal to 24. Yes, we have similar triangles. And if we have similar triangles, then we know that the angles must be congruent. Well, let's take a look. We already know that the 90-degree angle is congruent. That's a fact. But since we have similar figures, that means this angle down here must be congruent to that angle there. And the one up here at the top must be congruent to that one at the top of the green triangle. So using what we've already learned in the past about proportional side lengths making similar figures to then prove that those angles must be congruent. So now we're going to take that the other direction. From our lesson today, we're going to say, hey, if we can prove we have congruent angles, then we can prove that we have similar figures where we can use proportional side lengths potentially to solve real life problems. That will be in video number 2. But right now, we're going to tell whether triangles are similar or not, and we're going to explain it. So there's a couple ways of doing that. The first way I'm going to talk to you is, 1, you discover that they already give you one angle in each. I'm going to call this triangle 1 and triangle 2. We already know that there's a congruent angle, which is 43 degrees. So now we have to discover, is x equal to 59 or is y equal to 58? Well, again, we can use what we've learned before about triangles. We know that the sum of the interior angles of a triangle must equal 180 degrees. So I can use that to find either x or y and see if it's congruent. All right, it matches what we want. So I'm partial to x, so I'm going to take the first triangle, and I'm going to go x plus 58 plus 43 is equal to 180. Now I'm going to solve for x, and if that equals 59, I know I have three congruent angles and I have similar triangles. Well, when I add 58 to 43, I get 101, so I'm going to subtract 101 from both sides, and it says that x would have to equal 79 for us to have triangle. Well, 79 does not equal 59, so no, not similar, because they are not equal. Well, the other method we can use to prove that, don't write this down yet, the other method we can use is again, the sum of the interior angles. They've given us the three angle measurements that they say must be congruent to have these similar triangles. They gave us the 58 degrees. They gave us the 43 degrees. And they gave us the 59 degrees. And if those equal 180, then we have a right triangle. But when you add all those together, you only get 160. So 160 does not equal 180, so no, they are not similar. So two different methods. Some people find the second one to be quicker and easier. However, both work just as well. Go ahead and write that down and join me on the next slide. All right, welcome to our second example and telling whether the triangles are similar. And again, we recognize in triangle number 1 and triangle number 2, they've given us one angle that is congruent. That is the 52-degree angle. And so we have to discover, is x 80 or is y 48? Well, the first method from our last slide, we got x plus 52 plus 48 equaling 180. Solving for this, we add those two, we get 100. So if we subtract 100 from both sides, we say x is equal to 80. Well, in fact, x does equal 80, so absolutely correct. Yes, these are similar. Again, pens and pencils, everything down. You're just watching, listening, and learning right now. And of course, the second method, using what they've given us to say, hey, I've got angle 52 plus angle 80 plus angle 48. Does that equal 180 degrees? And of course, if you add those three together, 180 does equal 180. So yes, we do have similar triangles because all the angles are congruent. Our last example of the first video, I'm going to ask you to do it by yourself real quickly and then come back and join us so you can pause your video, work that out on your own, and then we're going to do it together. Go ahead and pause now and get this one done and see how we do. Alrighty, welcome back. So let's figure it out and see if our answers match. I'm going to go like this and say, hey, I've got this 90-degree angle that is congruent, and so I've got to find out, is x 47 or is y 43? And we're just going to make it quick. I'm going to use the second method this time, and I'm going to say, hey, I've got 90, because we know that this is a 90-degree angle, plus 43 plus 47, does that equal, 180? And of course, if I add these together, I know 43 and 47 is 90. 90 and 90 is 180. So 180 does equal 180. So yes, these are similar. Now, when you're in class tomorrow and you're asking questions, if you want me to show the other way, please do not hesitate to ask. Ladies and gentlemen, this pretty much concludes our first video. You do have a quick write that you have to do on your own, and we will figure that answer out together in class as we collaborate. So please pause your video. Get this one done, telling whether these triangles are similar. Of course, you're going to have to draw them and label the angles. No big deal. Take a quick break, get a snack, and then join us for video number 2.